this question, we have a triangle ABC, which is an isosceles triangle, and we have a point D that lies on AC, and ABD is a sector. So we know that this is a question about circular measure. We have to express the area of the shaded region in terms of r and theta. So to find the area of the shaded region, first we find the area of the triangle and subtract the area of the sector ABD. So the area of the triangle ABC would be half AB sine C. So half, we have the two lengths which are R and R, and we need the angle between them. So we know that the formula for an area of a triangle is half AB sine C. Now as these two lengths are equal, it means this angle would also be theta, which means that this angle would be 180 minus 2 theta. So the area would be half into R, which is R square, into sine of theta minus 2 pi. Now from our trigonometry, we know the identity that sine theta is the same as sine of 180 minus theta. So applying that over here, as pi is 180, in place of pi minus 2 theta, we can write half into R square into sine of 2 theta. So this is the area of the triangle. Now to find the area of the sector, we have the formula half R square theta. So it will remain as it is, as the radius is R and the angle is theta. So the area of the shaded region would become the area of the triangle minus the area of the sector. So this would become half R square sine 2 theta minus half R square theta. Now we can simplify this and write it as half R square is common. So we can write it as sine 2 theta minus theta. So this is an expression for the area of the shaded region. Now in the next part, it says, in the case where r is equals to 10 and theta is equals to 0.6, we have to find the perimeter of the shaded region. Now to find the perimeter, we need to understand that the length DC plus the arc DB and the length BC will basically make up the perimeter of the shaded region. So to begin with, we can write that the perimeter would be the length of BC plus the length of DC plus the arc length arc BD. Now to find the length of DC, so if we find the total length of AC and subtract the length of AD, we will be able to find the length of DC. So the total length of AC we can find by using the cosine rule. So we can write AC square. Now as we have the two lengths and the angle between them, so this, let's say this is C or AC. So we write AC square is equals to R square plus R square minus 2 times R cos of theta minus 2 pi. Simplifying this, we get AC square is equals to 2R square minus 2R square. And now applying the identity for cos, which is cos of theta is equals to negative cos of 180 minus theta. So as we have pi minus 2 theta, so this can be written as negative cos of 2 theta. So AC square would become 2R squared plus 2R squared cos 2 theta. Now we have the values of R and theta, we can substitute them up there. So substituting the values of R and theta, we get square root of 2 times 10 squared plus 2 times 10 squared into cos of 2 times 0.6. Finding this value in the calculator, we have AC is equals to 16.506 centimeters, or whatever the unit is. Now for the length of DC, it would become 16.506, which is the total length of AC minus the radius 10. So the length of DC would become 6.506. Now to find the arc length BD, we just simply use the formula R theta. So the arc length BD is equals to R theta. R is 10 and theta is 0.6. We get arc length as 6. Finally, for the perimeter, we add all the three lengths. So the perimeter would be the sum of the three lengths, and one of the lengths is R, which is known. We have the length of DC and the arc length BD. So it would become 10 plus 6. So this is the radius. This is the arc length. And this is the length of DC, 6.506. So this is the length of DC. So the perimeter would come out to be equal to 22.506. And as we have to give our answer in terms of in three significant figures, so the final answer would be 22.5. And we can, so it will be 22.5 centimeters as our units are in centimeter.